Okay, so here we've got a board that's partially wired up, and I wanted to go over the difference between a relay and a contactor now that you're able to see how this all works and how it's laid out. So again, the biggest difference between a relay and a contactor is that with a relay, you're only breaking one leg of the power, the hot side. Whereas a contactor, you're breaking the hot and the neutral side. And what I mean when I say breaking, I mean you're stopping the flow of this power, this 120, from going from this side of the contactor to this side of the contactor, or from this side of the relay to this side of the relay. Now, with a relay, the biggest thing you got to remember is a relay is very much wired up like this light switch here. Internally, we have your neutral wire, your white wire, coming from your power cord here, and it's wire nutted directly with this white neutral wire here. It's not going through the switch. So your white wire comes in off the cord, this white wire comes in off that bus bar, and they wire nut together inside this box. Now your hot wire, your black wire, comes in this cord, it goes in one side of the switch, and then it comes out the other side of the switch on this black wire, which then attaches to that bus bar. So the only thing that this switch is operating or shutting the power off or onto, or what I should say, allowing the power to either sit here on this switch or move through this switch, is your black or hot wire. Your relay is very much the same. As you can see, your neutral wire on your load is any power consuming device. In this case, it's the indoor fan motor. The neutral wire on that load is directly tied into this bus bar. It's not going through a switch, it's not going through this relay, it's going directly to that bus bar. Now, your hot side is coming off the bus bar. It's going here onto the incoming terminal on your relay, and it sits there, it's parked until the switch closes and allows that power to move over to this side, which then allows it to go to this motor. So how does it get switched? With our control voltage. Remember, our control voltage, or your 24 volts, is like this on-off switch right here. And your on-off switch is your thermostat. And if you remember from my previous videos, internally here, you have power parked on the R terminal, which is your hot terminal. And when you make a fan call and you move the switch to on, that power that's parked on R gets moved to G. And it comes off of G, and in this case we've used a green wire. It comes off of G, it goes through this green wire here, and it completes over to common and makes its way back to your contactor through common to complete the circuit. And when that circuit's completed, the contactor in here closes, and this power moves from this terminal to that terminal and then to your load. So your relay works very much like this light switch. So if we were to turn our power on, right now you've got 24 volts parked on the R terminal waiting to be used. When we switch this fan switch to on, it will move from R to G, go up through this wire, complete the circuit, and go through the common terminal to come back to the thermostat, close the switch, and move power from your incoming side to your outgoing side and to your load. And your load takes that power in, completes it through neutral here, and allows this to spin. So let's try it. Bingo. Now, how is the contactor different? The contactor, like I said, is splitting, or I should say is stopping both legs of power from going from this side of the contactor to this side of the contactor. You still have control voltage on the side. Your on-off switch is still here on the side. But this time, your on-off switch, which is your thermostat, is going to take that power that's parked on R and it's going to transfer it to Y. It's actually going to transfer it to Y and to G, because it knows that when you make a cooling call, because when we transfer power to Y, we're making a cooling call. Your outdoor fan has to come on, your compressor has to come on, and your indoor fan has to come on, right? If only your outdoor fan and your compressor came on, but not your indoor fan, then you're not cooling your space. And in fact, your evaporator indoors is going to turn into a giant block of ice. So it transfers power to both Y and G. So because one of them is Y, what is happening is that power is switching from R to Y. It's coming out this yellow wire on the Y terminal, goes into this contactor, completes it through common, which is the blue, which allows this contactor to pull in. This button here on the top that you see will pull down and pull in, and then the power that's parked here, your 120 volts that's parked right here, is now able to pass through and supply power to this fan motor and to this compressor. So if we were to turn our power on and give that a shot, you'll see that we will transfer power from R to Y and G. 24 volts will get sent out to both our contactor and our relay. It will pass through to common to complete the circuit and make our way back to the thermostat. Our contactors will close on both sides, and power will switch from this side of the contactor to this side of the contactor, or this side of the relay to this side of the relay, and power all of our devices. Now when this turns on, I'm going to unscrew this bulb a little bit, because when it turns green it makes it real hard to see what's going on down here on camera, but you'll get the idea. So we'll make a cooling call, and as you can see, everything's working. Now I unscrew the bulb so you can get a better idea of what's going on, but you get the idea. The power that was parked on our R terminal has now been switched to Y and to G. We've completed our 24 volt circuit on both sides. Our contactor pulled in, transferred power from this side to this side, and our relay closed, passing power from this side to this side. So hopefully that helps make more sense of what exactly is going on, and you'll have a better understanding of how this needs to be wired and why when you're doing it in lab.